angles 0, 30, 45, 60 and 90, where sin, cos and tan values are nice and exact.
No messy decimals. Knowing these values saves tons of times during your exams or tests.
Trigonometry is about the relationships between sides and angles in triangles. In grade 10, we will study these relationships in right angle triangles. The labeling of triangles. The sides of triangles are labeled based on their position relative to the specific angles. The longest side, opposite to the 90-degree angle, is called the hypotenuse. The side next to the specified angle is called the adjacent side. The side opposite the specified angle is called the opposite side. Note that we often use Greek letters like alpha and bravo to denote angles in trigonometry.
Which do you know what it is?
Ratios between the sides of similar triangles. As an example, consider the following two triangles. The smaller triangle ABC, the hypotenuse is equivalent to 2. The opposite side is equivalent to 1. And the adjacent side equivalent to 3 to the square root of 3. In the larger triangle, the hypotenuse is equivalent to 6. The opposite side is equivalent to 3. And the adjacent side is equivalent to the square root of 7. 27. And also notice that angle A and angle M are equivalent to 30 degrees. Definition of the trigonometric ratios. We define the three trigonometric ratios as follows. Sin equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Sides. Ratios between sides of similar triangles. As an example, consider the following two similar triangles. In the smaller triangle, triangle ABC, the hypotenuse is equivalent to 2. The opposite side is equivalent to 1. And the adjacent side is equivalent to the square root of 3. In the larger triangle MNP, the hypotenuse is equivalent to 6. The opposite side is equivalent to 3. And the adjacent side is equivalent to the square root of 27. Also notice that the angles PMN and CAB are equivalent to 30. The ratios between the sides of these two triangles relative to the 30 degree are BC over AC equals the opposite over hypotenuse equals half. AB over AC equals adjacent over hypotenuse equals 0. The square root of 3 over the square root over 2. BC over AB equals opposite over adjacent equals 1 over the square root of 3. For the larger triangle, BN over NP equals opposite over hypotenuse equals 3 over 6 equals 1 over 2. MN over NP equals adjacent over hypotenuse equals square root of 27 over 6 equals the square root of 3 over 2. BN over MN equals opposite over adjacent equals 3 over the square root of 27 equals 1 over the square root of 3. Notice that each of the different ratios remain constant for these two similar triangles. These ratios will remain constant for all right angle triangles with a 30-degree angle. In all right angle triangles with the same set of angles, the ratios opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent will remain constant. These ratios are called the sin ratio, the cosine ratio, and the tangent ratio respectively.
Angles are used in everyday life, such as physics.
Example 1. In the sketch alongside, or drawn on the page, angle A equals 60 degrees. Angle AB equals 1 unit. BC equals square root of 3 units. And AC equals 2 units. In this worked example, we will figure out A, sin 60 degrees, B, cos 60 degrees, and C, tan 60 degrees. For A, sin 60 degrees, we will put our opposite side over our hypotenuse side, which will give us square root of 3 over 2. B, cos 60 degrees, equivalent to adjacent over hypotenuse, which equals 1 over 2, or 1/2. C, tan 60 degrees, is opposite over adjacent, equivalent to square root of 3 over 1, which is equivalent to the square root of 3. In this example, we need to figure out the value of tan, the value of cos, and the value of sin. Mn equals 4 centimeters. NL equals 3 centimeters. We are working with a right angled triangle. For solution A, we need to figure out tan. Tan equals opposite over adjacent, which is equivalent to 3 over 4. 0.75. For B, to work out the value of cos, we first need to figure out the distance from M to L by using Pythagoras. Lm squared equals mn squared plus ln squared. This is the Pythagoras theorem. Lm squared equals 4 squared plus 3 squared. Lm squared equals 25. Lm, or the square root of Lm squared, equals 5 centimeters. Now we can work out cos. By putting our adjacent side over our hypotenuse side, we get the answer of cos equals 4 over 5. Now, for C, to figure out sin. We put our opposite side over our hypotenuse side. No extra working out is necessary, as we have already figured out all the lengths and angles of our triangle. Our opposite side, or our hypotenuse side, is equal to 3 over 5. For A, we need to work out the cos value. To work out the cos value, we need the length of TS, the adjacent side. To figure out TS, we need to use Pythagoras theorem. TR squared equals TS squared plus RS squared. This is as a result of the Pythagoras theorem. Therefore, 13 squared equals TS squared plus 12 squared. Therefore, TS squared is equal to 25. Therefore, TS, the cube root of TS, equals 5 units. 5 units. We can now work out the cos value. Cos T equals adjacent side over hypotenuse side, which is equal to 5 over 13. To work out B, we are figuring out the sin T value. Sin T is equal to opposite over hypotenuse sides. We substitute those values in, and our opposite over hypotenuse is equal to 12 over 13. Therefore, we now have our sin value. Tan T, opposite side over adjacent side, is equal
to 12 over 5. Therefore, we can assume that tan is equal to 12 over 5 using sides RS over TS.